Okay, write a method and draw a labelled diagram showing the apparatus required to determine the concentration of an unknown sodium hydroxide solution when supplied with 1 mole per decimetre cubed hydrochloric acid. So this is a 6 mark question. Possibly that's a little bit generous for the method, but I don't see why it couldn't be a 6 mark question. Either way, we need some volumetric analysis kits. So get a pencil and ruler out. Okay, it's my strongest advice. Otherwise, apparatus isn't always as clear as you might think. Okay, it doesn't take long to draw with a pencil and ruler. Okay, so we're going to need a burette and a pipette and a conical flask and things like this. Is just what I'm drawing here. A piece of apparatus a lot of people forget is white tile. We're going to place the conical flask on a white tile. The reason we're doing that is it makes it easy to see the colour change against a white background. Okay, so here's my, I put a tap at the bottom of the burette there. Okay, so here's my burette, and we're going to fill the burette with hydrochloric acid. Because we're going to add the hydrochloric acid very slowly to the sodium hydroxide, which we're going to put in the conical flask in here. So here's going to be our sodium hydroxide. The sodium hydroxide is going to be exactly 25 centimetre cubed. And we're going to measure that exact 25 centimetre cubed with a pipette. So a pipette is a very long, thin glass tube that measures exactly 25 centimetre cubed. To keep it very thin, there's often a bubble in the middle, a big glass bubble in the middle there. So that can take quite a lot of volume, and the line will be at the top here. Okay, so this is my pipette, and I'm just going to have a beaker of sodium hydroxide here that I can suck my sodium hydroxide up into. So there we go. So this is my sodium hydroxide, and we're going to measure out that exact 25 centimetre cubed into that pipette, P-I-P-E-T-T-E. And then once we've done that, we put that into the conical flask there. So there's my apparatus. Let's label that conical flask. Let's label that white tile. We've forgotten to add the phenolphthalein, haven't we? Sodium hydroxide, there's going to be sodium hydroxide in there, and we need an indicator, a suitable indicator. Phenolphthalein works a treat. Okay, now we need a written method with our apparatus. So firstly, I do some bullet points, I just find that easier. Fill burette with hydrochloric acid. So we need to name the burette, that's really important. Okay, measure exactly 25 centimetre cubed. I'm just going to use the symbols of sodium hydroxide solution with a pipette, and it's important you name the pipette as well. It's the most accurate piece of kit for that task. And place in a conical flask with a few drops of phenolphthalein indicator. Okay, so we've now got that all set up under the so we've now got all that set up, yes, over here like this. We need to say, of course, we're going to place this on a white tile. Place conical flask on white tile under the burette. Spelt incorrectly. B-1-R-E-T-T-E. Okay, so next we're going to add acid slowly, swirling all the time. And we're going to stop when the indicator goes from pink, because it's going to be pink in the alkali, and it goes colourless, don't say clear, it goes colourless when it goes neutral. Okay, we're going to record how much acid was added. Then we're going to repeat twice more, at least twice more. Or until concordant results. Okay, we're then going to average those, and we've got our volume of acid needed to neutralise the alkali, and we can do a calculation to work out the concentration of sodium hydroxide. All these questions on elshramhighchemistry.com.